Welcome to this talk about supercharging data modeling with cloud-native features for cost effectiveness and efficiency. And this is the modern data stack theater. We're talking about cost efficiency in cloud data platforms, and yet we're talking about data modeling, something that originated in the 1960s with Edgar F. Codd in the relational database. So why are we still here talking about it? So this is what we're going to look at today. This is me, this happy fellow. A little bit of background. I started my data career in the SAP world, so SAP BW, HANA, BO. I transitioned then to Snowflake and cloud data platforms. I am now working for a vendor which makes a cloud database modeling tool, SQL DBM. I'm the product success lead. I'm also a Snowflake superhero and recently author of a best-selling book, Data Modeling with Snowflake. So I've been giving data modeling a lot of thought, especially recently. And before we even start the talk, I wanted to reach out to you and ask you, first of all, since we will be talking about efficiencies, cost, driving down operational costs, increasing communications within the business. So I actually just wanted to know, because you showed up, why you did and what kind of issues you might be facing, especially from a cost perspective, from an efficiency perspective, time, etc. What are you facing in your day-to-day jobs? So just reach out, raise your hand, someone will hand you a mic, and everyone can hear your question. Sorry, 1 second, let me put on these headphones so I could hear you too. I can't hear you. Everybody's on.
Is that better? Yeah, that's better. I've actually done quite a bit of work on...
Sorry, I'm hearing someone else. It sounds like a dude, which is probably not you coming through those headphones.
I've actually done quite a bit of work on FinOps, and for that platform it's Azure and understanding our cost bill. But I'm our sort of UK admin for Snowflake, so I want to do the same sort of thing in Snowflake.
Okay, that's wonderful, because FinOps is going to figure prominently in this talk.
Right.
Anybody else?
Okay. I think on the efficiency side, I'm looking to see, how I'm data management, so how do we keep our physical databases in line with our logical data models, in line with our data catalogs? How do we kind of keep all that within kind of the modeling tool?
Great. Okay.
Thank you.
Anyone else? We could do one more, or we can move on. Let's go ahead.
So mine's around modeling for data sovereignty, which is becoming a big issue now. So understanding how we can model that without having to duplicate all time and again.
Thank you. So unsurprisingly, what didn't come up in any of these questions was something you never hear, which is a challenge for modern organization of we're just not that great at SQL. We have all these queries that we wish we knew how to write, but we just don't. Or we have the technology, we just haven't figured out how to get one piece to talk to the other piece. The concept that we're going to look at today is exactly what you voiced just now in your questions of understanding, simplifying, and getting that to be the driver of efficiency in what you end up building in these cloud data platforms, and especially why it's more important than ever. So you might recognize a little bit of this terrain. The reason I have this up here is to remind people what a model is. There's a lot of overloading of this term, especially in the modern data stack. DBT calls any table they create a model. There's logical modeling, there's anchor modeling, there's conceptual modeling, lots and lots of modeling. knowledge graphs, all sorts of models. Because what is a model? Just like we see up here, a model is, simply put, a simplification. It's something that lets you break something down and understand it at a high level before you dive into the nitty-gritty. So the Google map is a great simplification of the actual terrain of London. You can look at it from a top level to orient yourself where things are in the city. You can zoom in all the way to city blocks and understand how to get around from one corner to another. But the map is not the territory, famous refrain. And a model is very similar to a map in the sense of, when we're talking data, it really is a blueprint, a map of your data assets, your schemas. Again, without really getting into too technical of a start right off the bat, I wanted to start with a story which involves no data at all, but it does involve modeling. And this takes me back to high school. And in high school, I took woodshop. In woodshop, there was one project that you spent the whole semester doing, which was, we had these big, bulky wooden work desks. And the project was to make a model of it, a 1/8 size model to scale. And before you can make this 3-dimensional wooden model, you had to make a 2-dimensional 2D map, measured scale diagram of what this thing would look like piece by piece. And we had a teacher, stereotypically missing a finger, and he told us on day one and every day since, measure twice, cut once. When a man with 9 fingers tell you this, you listen. Except if you're 15 years old, you think you know everything, and you measure once, and you do it like an idiot, and you start with 1 on the ruler instead of 0. So you cut your very first cut a whole inch too short. And now guess what? It's just a piece of wood, but this was the baseboard. So from that point on, what I just did is I made it so that my model didn't match reality. Any cut I made at that point on, even if it was spot on, measuring from 0, learned my lesson, there'd still be a gap. Something wouldn't fit right. And what did that mean for me as a student in this class? It meant that I had 2 options. I could either accept the fact that what I built would always be out of whack. Things would either be too long, too short, it would look weird, it would look funky. Or for every cut I made subsequently, I would have to do rework. I would have to readjust and say, okay, well, if this is now an inch too short, I would have to scale everything down to make sure that at least now we were still matching reality and what, in this case, the business user, the professor, expected to see at the end of the class. He wouldn't penalize you for the scale. He would penalize you for ugliness. And this is the number one problem in data warehousing and data in general, of speaking to the business, understanding what your users expect, what your data looks like, and then what do we end up doing when things go wrong? Rework, building one thing but the user meant another thing, going back to the drawing board, redesign, avoiding surprises. If I was expecting this granularity but I got another, how come this doesn't match? Where is this piece? Because now that we can, let's shift into something more technical, the actual modeling and data modeling itself. A data model is, again, an abstraction, but it's a very useful abstraction. So it's also something that tends to scare a lot of people. There's a lot of stigma, there's a lot of arcane terminology and symbolism that's crept into data modeling. There is a standard, but there's lots of standards is the problem. So you can pick any one you like. Some are a little bit more arcane than others, some are a little bit more intuitive. But the important thing I think to keep in mind is that when we talk about modeling, we talk about it in the domain of the data team, the data architects, when really a model, before we can even talk about a data model, we need to talk about the business model. because you don't just design tables for the sake of designing tables. What attributes are going to be in those tables, what they're going to look like, what the elements and relationships are that join these tables together. This is not a technical question. There's a technical right way to build it once you've identified them, but which columns are going to be in a table is not a technical question and can't possibly come from the data team. This is something that you need to sit down with your subject matter experts, your domain experts, your business users, and ask them the very simple question of, what do we do here? What is our business? And that's when you start to have this conversation without confusing them with identifiers, constraints, type 2 dimensions, unique keys. Just tell them, what is a customer? Can you define a customer for me? And which attributes, which properties of customer do we care about as a business? A customer, might have something like a favorite color, but it's dubious whether we really want to store this information and if it will help us in our analytics in any way. Unless we're a clothing brand, then maybe we do. So let's go over to the next slide, which we've already begun talking about. Modeling traditionally kind of takes place along preset types of modeling. It starts with conceptual, which really doesn't need to be any more complicated than boxes and lines. Again, there's no firm standard to say you can have attributes in conceptual or it has to just be entities and relationships, and as some people have pointed out to me this morning. And then you move on to logical. Why is conceptual useful? Because it's easy to understand. There's nothing technical about it. You can sit down over a sheet of paper or a whiteboard or a modeling tool that'll just show you rectangles and relationships and maybe attributes, and you can ask your business users, does this make sense to you? Is anything missing? Because again, when you measure twice, it's going to be a lot more expensive to fix these things down the line. You can always add an attribute, sure, but once your granularity starts to change, once your relationship starts to change, then we're talking about pretty costly rework, which we're going to get into costs in just a minute. So a conceptual model translates very nicely and easily into a logical model. In logical, there's, again, not to alienate anyone, I'm sure a business user can perfectly understand a logical model if you keep it simple, use maybe standard Baker notation, and show them what are the attributes, what are the basic data types. You don't have to get into int, varchar, 32, comma 2. Just tell them this is a string, this is a number, this is a date. Does this make sense? Is a customer ID a string? Does it have any dashes, or is it just a number? Does it have symbols, etc.? And the next step is, before we get to physical, logical can also capture a lot of nuances that databases simply don't have constructs to store, which, for example, relationship names, descriptions like owns, has, contains, is member of, help you to understand the relationship line itself and how things link together. Things like many-to-many relationships, subtypes and supertypes, or basically classes and subclasses if you come from a programming background. These are nuances that no matter how you structure your physical data, you just can't know. As you see in philosophy, does not imply ought. Just because something is a certain way or is built a certain way tells you absolutely nothing about what it should look like, or is it even meant to look like this. So leading on from logical, we get into physical. Physical now is specific to the database platform that you're working with, whether that's on-premise, whether that's in the cloud. Now we are concerned about not just the business element of a model, like what is a customer, what is an order, how many orders can a customer place, who's the shipper, the supplier, and things like this, but what is our system optimized for? Do we need indexes? Does our system even support indexes? Do we need clustering? Do we work better with normalized or denormalized data? So now, these are not terms I would throw in front of a business user, but these are very important once we start talking about costs. Because as we are talking about the modern data stack, so price is what you pay, value is what you get, right? What has been the major shift in FinOps when it comes to data in the past decade, maybe more, ever since Redshift, Google BigQuery, now Snowflake and Databricks came on the scene? We're talking about CapEx versus OpEx. And as many of you know, you'll be able to say CapEx is the equipment, OpEx is the people. That's what CapEx and OpEx is, right? That's part of it. The part that people often overlook in terms of CapEx and OpEx is the capitalization itself. It means where can we, on the finance side, attribute value? Is it in the current period or is it sometime in the future? So if I've bought a car, I've got it for the next decade. I can drive it around. I made an initial upfront investment, and I'm going to make good use of it. And if I take care of it, it might last me longer. But if I've paid an employee to come and do some work, let's say I paid a plumber to fix my sink, that value is realized right now in the moment, in the current fiscal period. So part of this equipment used to be things like databases. You bought a database, it sat somewhere in your server room, you wired it up, and you owned that machine. You might have had additional licenses, which you can then distribute over time as OpEx, but the hardware was CapEx. And it meant when you built your physical data model and any analytics you would then run on top of this data model, cost never really figured into the picture, because a query is a query. It can run for a half an hour. If it runs quick, great. If it runs for 6 hours, we'll just schedule it overnight. I don't pay anything extra. But with the modern data stack, all of that got flipped around. So I come into work in the morning, but now imagine my database also comes into work in the morning, which is literally what the modern cloud data platforms allow you to do. They allow you to turn on an appliance just like you would the lights, to say, and not just an appliance, but an appliance scaled to the demand that you're going to put on it. So I can have a warehouse scaled for analytics or my light business users. I can have a warehouse scaled for ETL and parallel loading. I can have a warehouse that's now a little bit more power-packed but doesn't require so much parallelism to handle heavy ML workloads. And I could pay for exactly what I need. And when I do that, this whole equation flips on its head in the sense of it's now on me. I can't just sit back and say, okay, so it ran a little longer, or let's load this nightly because it's going to take so long. Nightly or not nightly, you're going to get smacked with a bill at the end of the month. So there's an extra onus on efficiency and not doing extra work, not doing the readjustments, because again, you will be billed literally by the second in exactly which queries you ran, how much processing they used. And this is where efficiency really comes into the picture. And let's see if we go on to the next slide. Actually, let's hold off. When we're talking efficiency, the model, again, before we were talking about the business side, and if we've done it properly, we have brought the business into our workflow. We've made them a partner in this process, and we've helped them take the reins and drive exactly the base layer of what we're going to be designing. But because we did that, and because we worked with them and transitioned this from idea to just the box with attributes, to attributes with correct data types for efficient compression, efficient querying, partitioning, clustering. Again, we're not going to dive into the specifics of any one database or platform. For example, Google BigQuery famously prefers denormalized data, big tables, Snowflake can do really great things with join eliminations, star schemas that you can give all the attributes kind of together in one view or in one query, and if you don't pick any attribute from a certain dimension, we can just not execute that query. So with again using going back to modeling, this is done through your primary and foreign key or alternate key constraints and the rely property. So the fact that we even have these constraints and we knew where to put them means, again, we're starting off with that business model of what the user told us they expect to see. And then now if we're talking about cloud data platforms, these tend not to be the operational transactional systems. These tend to be the analytic systems. So they, in a way, inherit the model because we ETL it over. A lot of people say, oh, I don't do modeling, or yeah, I do modeling through DBT. Of course you do modeling. Sometimes you take it for granted because the table lands in your raw layer or your source layer, but somebody has done the work. And whether you spend that time once your user says on the data warehouse side, what are our customers' sales by segment? What are our customers streaming on a certain night, 1 week compared to the next week? These are no longer questions about entities and relationships. These are operational business questions. These are analyses by definition. So when your business users ask, okay, can you give me this breakdown or can you give me this drill down, whether mentally or through a dedicated tool or whether on a whiteboard or a paper or an Excel or in Visio, whatever, you're looking at the data model saying, okay, they just mentioned customer segment. Let's say I just started. I don't know what this, I just walked off the street. I'm a new analyst. Where can I find this item? I can always refer even to the transactional or the operational systems model and say, where does this field sit? How does this table relate to the fact table that I'm building? Are the cardinalities of these two things that the customer is describing, are they aligned, or will they duplicate my KPIs once I bring them together and join them? And because I've done it right the first time, I've measured, I've laid it all out on a blueprint, and I've walked through this exercise with my stakeholders, it means I don't have to go back to the drawing board a week later when they say, what the hell is this? So there's a lot of time we're very good at measuring query performance, and once we were measuring query performance, we're very good, and modern data platforms and FinOps are very good at being able to tag even your queries and assign quotas to them in terms of warehouse spend, so you can very easily have a analytics team with a compute quota that you can now budget for ahead of time and say, for the type of queries you run and the type of analytics you do, we're gonna allot you 500 pounds or dollars a month or $2,000 a month, or we've got a budget for this project, and we can start this in a very scalable fashion of we can have a POC on the cloud with a very limited data set which costs nothing to spin up. We can see if this gains traction, if this meets user expectations, and then we can scale out the data and then our warehouse footprint for the spend that we're going to be using. Because for the first time, when you did a project, let's say on an on-premise system, you bought the system up front. And just like a car, you would say, I would be using this for the next 5 years. But when will you realize the value of that big investment? And a lot of times with licensing costs and servers and everything up front, we're not talking trivial investments. We're talking millions of dollars up front. But on day one, you've got nothing in the system. You've spent $1 million or $5 million, and you've got nothing to show for it. Over time, you're going to start loading data, adding projects, running reports, building dashboards. But you can argue that the only day you live up to that system's full potential is the day you max out on storage or processing power, and you need to buy a new one, scale out or scale up. With the advent of the modern data cloud, you can make cost and budget an ally in the sense of justifying what it is you're doing, both to the good and the bad, in the sense of, just like I said earlier, to justify an on-premise system before the whole business department, every department had to come together and put their heads together and say, okay, you're going to do this project, I'm going to do this project, we'll pool our resources and we can buy this thing. Now you can work with individual teams and say, we can have a data warehouse, central governance team or central data team, build out the golden source of truth. We can do it safely so that you cannot, as an analyst or a user, you can't bring down our system. You can just reference our data, you can zero copy clone our data, make use of it, and you can tell us in advance exactly what you plan to do and how much you plan to spend. So what is this project worth to you? Before, it was nebulous on an on-premise system of, we're just going to do stuff. We have to we have to justify the expense. Whereas now you just tag your queries, tag your warehouse, and let your users come to you ahead of time. And with the analytics team, again, a user is not going to be able to estimate query cost, but you can very easily help have that dialogue over a data model of saying, these are our structures, this is the way it looks, and these are the types of volumes you can expect to have. And then the user can actually say, actually that's a lot of investment up front and probably not worth what I'm planning to spend it on, or I'd rather prefer to do it kind of in my head or in Excel, or it also serves as a tool for keeping them honest once they've done the estimate and said, we're going to require $500 a month or $1,000 a month. You can keep them honest and say, okay, you know what, you just ran out of credits because you said you were going to do this, and here's all these new analysts running more queries. Do you need to ask for more budget or do you not? And you can actually sit down with them and say, what are your longest running queries? And you're not just giving them a bulk number. You can say, what's the 80-20 of this cost breakdown? What took you what consumed the bulk of these credits? And is this what you envisioned when you first laid out the plan for how you'd be spending this credit budget? So we're almost out of time, so I wanted to make sure I gave an overview of the best practices and everything that we've spoken about in this talk. So first and foremost, if we can phase out the word data modeling and talk about business modeling, I think we would be doing a tremendous service to the industry and our users. Work with these business users to conceptualize first, agree, and use. Again, it's not about showing how smart you are and how many notations you can understand. It's about agreeing on a notation that your business users can intuitively see and make sense of. And use that as a tool to foster these communications and bring them in. And when you bring someone in, you make them invested in what it is you're building. You understand ahead of time the direction that you're headed in. From then, you as a data team can take that and evolve it, add your functional semantics, understand a little bit of, even though these are going to be 3 tables in a database, but this is actually a many-to-many relationship of just 2 entities and the interactions between them. Add your technical accelerators. Again, how big is this table going to be? Do we query it by time or last loaded? Can we add partitions, or do we always query by individual needle in a haystack, and maybe a cluster would be, or an index would be a better idea? These are, again, things that are going to influence your day-to-day cost on the cloud data platforms, whereas before it just meant you waited a little longer. And finally, make it a team sport, kind of bringing everything together into one. Make it a team sport, because the data team is never going to understand the data as well as the business team does, the operational team. They're going to be able, if you work with them, they're going to be able to make it efficient and correct, and making sure that, when you said you're going to make a table, you cut it in the right place and it looks like the table you set out to make, and your business user is happy. But these are the things that when you make it a team sport, there's no surprises. They're with you every step of the way, your SMEs, your business users, and you can justify the costs at the end of the day. You say, this isn't just something I dreamed up. this was a project I built with the marketing team or the sales team. They had this much spend. They said we're going to run an initial set of queries, and this is what we built, and maybe we need more, maybe we're good, but if we need more, we can easily justify it. So we're out of time, but thank you so much. I'm happy to take questions outside, or you can come visit us at our booth at SQL DBM. We'll be there till the rest of the day. But thank you so much for attending and keeping us company.